You've probably seen those pictures, right? These majestic icebergs just floating peacefully in the polar seas. But, believe it or not, beneath that calm surface lies the potential for something so violent, it's often described as an explosion. So today, we're going to break down the incredible physics that cause these frozen giants to suddenly and catastrophically flip over.
To really get a sense of what we're talking about here, just try to picture a skyscraper made of pure, solid ice. Now imagine that whole thing violently rotating from top to bottom in just a few seconds. I mean, the forces involved are almost impossible to wrap your head around, and it can create massive waves and shock waves you can feel for miles.
And that really brings us to this central mystery. It's one thing for an object to tip over in the water, but why do people who've seen this happen describe it as an explosion? Where does all of that incredible, violent energy actually come from? Well, that's the big question we're going to answer.
Okay, first things first. This isn't a chemical explosion like you'd see with dynamite. Nope. What we're witnessing here is purely mechanical. It's a massive, sudden release of stored energy. The best way to think about it is like a huge rubber band that's been stretched to its limit and then suddenly let go. The energy was there the whole time, just waiting for a trigger.
Now, the secret to all this stored energy starts with a fact you've probably heard before. What you see of an iceberg is only about 10% of its total mass. The other 90%, this vast, hidden shape under the waves, is what really controls its stability, or its potential to do something really dramatic.
So, why does an iceberg flip? Well, to answer that, we kind of have to start with why it floats in the first place. It's all a delicate, constant battle between two huge forces. You've got gravity, which is pulling the entire mass down, and you have the buoyant force of the water pushing it right back up.
In a perfect world, an iceberg finds what's called buoyant equilibrium. It just settles into a position where it's perfectly balanced, displacing just the right amount of water to support its own weight. That's its most stable state. But here's the catch. Icebergs are born from glaciers in all sorts of jagged, irregular shapes. They are almost never born in a perfectly stable position.
And this brings us to two really critical ideas. The center of mass, that's the balance point for the entire iceberg that parts both above and below the water. Then you've got the center of buoyancy. That's the balance point for only the part that's submerged. For an iceberg to be stable, those 2 points have to be lined up perfectly, one right on top of the other. The moment they get out of alignment, the iceberg gets wobbly, kind of like a spinning top that's about to fall over.
So an iceberg doesn't just wake up one day and decide to flip over. No, it gets pushed over the edge by a bunch of hidden forces, saboteurs, if you will, that are working away, sometimes slowly, sometimes suddenly, to mess up that fragile balance we were just talking about.
And there are a ton of factors at play here. Things like ocean currents, internal cracks, even big rocks and debris that are frozen right into the ice, they can all shift its balance. But the biggest culprit, by far, is melting.
You see, melting is constantly reshaping the iceberg from every angle. But it's the underwater melting that's especially dangerous. As warmer ocean currents eat away at the submerged part, the iceberg actually becomes top-heavy. This makes its center of mass rise higher and higher, pushing it ever closer to that tipping point.
And the danger isn't just on the outside. As the surface melts, that water can pour down into deep cracks inside the ice. The incredible pressure from all that water can actually force those cracks to get bigger and bigger. It's a process called hydrofracturing. This can cause the whole structure to suddenly fail, just shattering its integrity and triggering a flip.
So let's go back to our big question. What makes the flip look like an explosion? Well, it's a perfect storm of all these different things. As the ice cracks and rolls, you have ancient air bubbles trapped under immense pressure for thousands of years that suddenly burst out. You have jets of meltwater shooting out like fountains, and the sound of billions of tons of ice cracking creates this thunderous roar. It all happens at once and, yeah, it looks like a genuine explosion.
Now, this isn't just some cool physics lesson. It has really serious real-world consequences. As our planet keeps warming up, understanding and even trying to predict these events is becoming a huge challenge for scientists, and really for anyone who has to travel in polar waters.
And to put that power into perspective, scientific instruments have actually picked up the tremors from these colossal iceberg flips. They register them just like small earthquakes. I mean, we are talking about an energy release on a geological scale here, and all that energy has to go somewhere.
The fallout can be absolutely devastating. A flipping iceberg can easily capsize a ship that gets too close. If it happens in a confined space like a fjord, the wave it creates can be like a localized tsunami. This is exactly why sailors in these regions give big icebergs a very, very wide berth.
And here is the really crucial part. Climate change is basically pouring fuel on this fire. As the oceans get warmer, that underwater melting speeds up. As air temperatures rise, you get more meltwater on the surface, which leads to that hydrofracturing we talked about. This means these violent flipping events, they're probably going to become more frequent and even more energetic.
Okay, so let's pull all these threads together. What is really going on during this incredible violent rebalancing act? The power source, the fuel for the flip, is what's called gravitational potential energy. An unstable, top-heavy iceberg is just like a huge boulder sitting right on the edge of a cliff. It has a massive amount of stored energy just because of its shaky position. And the flip? That's the moment the boulder finally falls.
So the whole sequence really unfolds in 4 key steps. First, that instability builds up slowly, over time, as the iceberg melts and drifts around. Second, some final trigger, maybe a big wave or a sudden crack, pushes it past the point of no return. Third, all that stored energy is unleashed in just a few violent seconds. And finally, the iceberg settles into a new, more stable position.
So the explosion isn't really a thing, it's a process. It's that moment when all that stored potential energy gets violently converted into the kinetic energy of motion, the acoustic energy of sound, and that incredible spectacle of flying ice and water. It's nature rebalancing itself on a truly epic scale.
And here's one last amazing little detail. When an iceberg flips, it often reveals this deep, beautiful blue ice that hasn't seen the light of day for thousands of years. This ancient ice contains a perfect record of Earth's past atmosphere, giving scientists this invaluable snapshot of ancient climates. So even in all its violence, the flip actually reveals secrets.
Which, of course, leaves us with a final, pretty sobering thought. The flipping of an iceberg is such a powerful reminder that the frozen parts of our world aren't static at all. They hold immense and sometimes incredibly violent power. So as we continue to change the climate that governs them, you have to wonder, what other forces will the melting ice unleash?